Last video we actually stopped for the YouTube meter. Okay, so this video will talk about measuring gauge pressure difference between two fluids. Okay, between two fluids in two different containers. Okay, so what is the difference between this following thing and the YouTube meter? Is that this one is the difference between the this is to find the specific gravity for this fluid. For this configuration is to find the difference in pressure between these two fluids. Okay, how this fluid and this fluid interacts will cause a pressure difference. Okay, what is the pressure difference between these two fluids? But this one is just to simply measuring one of the fluid itself. So maybe if you want to measure this fluid, you can actually measure this one. So but however you cannot measure what if they actually um interacts, what will happen. So this is one findings people want to find, so therefore they created this thing. And therefore our purpose here is to actually solve for the relationship to eventually get a difference in pressure, PA minus PB. Okay, point A minus point B. Okay, this is what we're gonna do. Point A's height is lower than point B so the pressure itself on this is much like higher than this. So therefore we're gonna measure. So with this said, let us look at the following. Okay, deriving the formula. So typically you will have to find a point in the fluid. Okay, first you already know that there is point A and point B. Okay, you have to really go and check it out. And then point A is you can see that point 2 can be can be can be described using point A, right? With like point 1. So point 4 can be described using point B, okay? And then point 3 can be described using point 4. So you have to identify the points that are which point can be described by which points. Okay, so this is what the things are, okay? So and then you make a relationship with all these points, and then eventually you get when you get an equation that describes all of the points, again 1 2 3 4 5. If you have the equation that describes all of them, then you're safe. Okay, so this is what I actually written here. How do you know your final equation is good? So this is what I just said earlier. And therefore let's start. So the first, as I said earlier, relationship between P1 and P2. Okay, this is so P1 and P2 is written is formed by P1. So whatever changes in P1 will cause changes in P2. So therefore P1 is equals to PA. Okay, they are of the same height, and therefore P2 is equals to P1 plus this. Okay, this height. Okay, maybe I should write. So the amount of rho GH over here plus whatever pressure at this point is equals to P2. Okay, so this is what it is. P1, which is P1 over here, and the rho GH here. And therefore, since P1 is equals to PA, as I mentioned earlier, this relationship can be rewritten as PA. Okay, while rho 1G is actually specific gravity, so we can rewrite it as specific gravity 1. This you should know, okay? If it don't ring a bell to you, then you should go and check it out, okay? That means something is wrong with you. And then relationship between P2, P3, and P4, okay? So now, since we know P2 is related to P1, similarly from last video we talked about setting P2, and then P2 is in relationship to P3 type of thing. So in this case, P2 is also in relationship with P3. They are of the same point, and therefore P3 is equals to P2, right? So yeah, so P3 is equals to P2, and P2 equation is this, right? PA plus rho 1 H1. So we just sub it over here. So it's du is the same as this, right? This is P2. So since we say that P3 is equal to P2, so this portion is the same as this. Okay? And therefore, it is equals to P4 plus rho 2H2, okay? So where the hell is P4? P4 is over here, okay? This is P4. P4 plus this amount of pressure can be described, can describe P3, okay? So P3 can be described using P4 and the relationship, and P3 can also be described using P1 plus the amount of over here. So P3 can be described using these two relationships. Okay. So this is why I've written a relationship between P2 and P3, P2, P2, P3 and P4. This is the point. Okay. And then we have this already. We rearrange this portion. Okay. Since we know that P3 is equals to this one and this one, we rearrange this and this. Okay. Since this is equals to this, so you rearrange in terms of P4, okay, because we know that we have to incorporate point 5, which is the point B, okay, the fluid point where we want to measure. So P5 itself is, therefore this is rearranging only. P4 you will get this one. So if you wonder, you just this one is equals to this one, okay? So you just bring this towards minus. So P4 is equals to this, yeah. And then relationship between P4 and P5, okay? So is that P5 is equals to PB, right? P5 is equals to PB, as you can see. And then P4 can be represented by P5. Okay, P5 is equals to this relationship, right? P5 plus rho 3 H3. Okay, so it is this. Okay, and make sure that you know that this fluid, the density is different from this density. Okay, so this is why. And then there is three type of fluid inside this whole system. Okay, one is this pink color one. Second one is this one. Third one is this one. So there are three type of fluids. And our purpose is to find two of the fluids. I mean difference between these two fluids. Pressure. Okay, pressure difference between these two fluids. And having to know this relationship, okay, that P5 plus this thing equals to P4, we have this over here. Okay, this is PB is P5, okay, plus rho 3H3. Since we have all the equations, okay, since P4 can be described, this can be described by this one and this one, and that in this case P4 can be described also by this length. So this is equal to the changes in this point and this point, if you were to say so. Okay, so what I mean. So explicitly in terms of length, if this changes, okay, if this thing push down, this one will change, right? This one will actually become shorter. Since this one, they're connected, so if this one shorter, this one will come out. So this one will change also. So this two changes will cause this thing to change. This thing change, this two will change. So this is the relationship that you can see from our equation. And our equation, these two equations, okay, P4, since they are equals to P4, so this is equals to this. So this is why we have written over here, okay. Blue color, which is the portion over here and here, is being rewritten over here, and P4 equals to PB plus this over this portion, so it's rewritten over here. So we have just rewritten our two equations into one equation, and we rearrange again, we get PA minus PB, and then you just bring this rho H1 over here, you'll get this. And you may wonder, previously I was saying, after making a relationship that can relate two or more fluids together, we can then solve for pH using for the the P gauge equation, P absolute minus um, you know, minus P atmospheric. However, in this case, there is no atmospheric because you didn't expose anything to the air, right? And therefore, this equation is somewhat like this. So this PA minus PB is actually B gauge, while this whole thing, okay, this whole thing is P gauge. I mean P absolute, while P atmospheric is 0. So therefore, the P gauge is equals to P absolute. And what rings a bell to me is that then how do we find the difference in pressure? Okay, that is I also don't know how to find, which is yeah. So my intuition tells me that we have to use simultaneous equation. I may be wrong. Okay, so yeah, maybe in the future then yeah. So as you can see, maybe I should hold on a while. So in order to solve this pressure difference, okay, one thing I thought of is given that we actually know that the density and the density of container one, that means we already know the density of these two fluids, okay, beforehand. So in order to know the density of this fluid and this fluid individually, okay, if you want to know in fluid A's density, you can actually use the YouTube thermometer. Okay, so similarly for if it's fluid B, you can also use this one to measure density first. Once you get the density, you know the variables, and this one is a known fluid. So therefore, you have fulfilled the equation to solve for the difference in pressure. However, if you don't know this and you don't know container one and container two, I mean you don't know the fluid inside them, the density of these two fluids, one of the method to solve for it is actually using simultaneous equation. Okay, as seen, the gauges are actually drawn over here in my color, so maybe this reflects maybe 5 meters. Okay, I mean 5 cm, sorry. Then maybe this is like 0.5 cm. So with this, we can actually see the height. So we can calculate our height. So since we know that our known fluid is gamma 2H2, okay, this thing, we can simply sub in whatever values that we know for this. So in this case, as you can see, okay, this equation here is the same as this equation, and then I actually write the difference in pressure in terms of difference in rho dHd. This is the difference between the pressure. So I just rewritten this portion as this only. And therefore, since we know H2 and rho 2, I will assume some values, let's say plus 5. Let's say it's 5, okay, let's say this is 5. I bring this over, which is minus 5, sorry. This will be minus 5. You give me a minute. Yeah, so this is minus 5, this is 5 because rho 2 H2, okay, is a known fluid, we know our density, we know our height. So we can know a numeric value for this. And then we just bring this over and we bring this difference in pressure over here. Okay. So the difference between row 3, the difference between these changes and these changes is equals to these changes over here. Make sense? I mean, okay, sorry, the difference between these changes and, hold on. The difference between these changes and the pressure difference will result in the changes in this, which totally don't make sense. Good job. Okay, okay. So just don't intuition no, but rather than this thing when this is the difference in pressure, right? So you may wonder why is the 3 and 2 and 3 over here. It's just well, just sub in whatever value for height. Okay, since because we can easily measure the height, so these values are easily being shown over scale over here. So this is why we have the coefficient in here. So I just bring this over. So this is an equation that describes the relationship of all these things. Although I can't describe it in terms of graph. in terms of this diagram. But however, if you know that there is three variables, okay, you will need three equations to solve simultaneous equation. Therefore, one method in order to solve this difference in this density, this specific gravity. Okay, one method is to change the container size. So maybe we change it to be a slightly smaller size, and then we bring measure again, and then we change this to a slightly measures smaller size, and we measure the everything again. Then we have three equations. We have three equations ready, and then you can solve using simultaneous equation. So this is one method, and this is the only one method I thought of it lah. Another method is given that we find the specific gravity of the fluids in container 1 using YouTube thermometer, and then after that, so we have to make known of our density, our specific gravity, in order to calculate for the difference in pressure. So I've talked so much, okay, and maybe in the next video I'll just do a summary for all of these things, and then hopefully you'll know what I've. Maybe I should do a bit summary for this thing. So the key thing actually is the derivation for this part only, okay? You don't actually need to care about what I've said earlier. So the key concept here is only this part. How do you want to set up an equation for this in order to solve? For all these things, once you reach here, I believe in the test they will give you all the parameters so you can actually solve them easily. But this is my understanding. So actually didn't tell you earlier, so yeah, waste your time, but whatever, if you're interested, you can still continue to dwell upon. So mainly it's just to find a point in the fluid. Okay, find whatever point in the fluid, and then you use this point, see whether can this point be described. Can you use this point to describe other points? Okay, so I can use this point to describe the point in P2. Then I can use P4 or P5 to describe the point in P3. So you try to set up an equation that can describe all of these points. Okay, 1, 2, 3, 4, 5 that is labeled in the graph, or I mean in the diagram. And then after that you use in order to know whether your final equation is good, you have to make sure your equation incorporates all of the points. Once you see that your equations contain all of the points, let's say for example, in this case, we contain point 3, point 2, and point 1, okay? And then you know that although it's not in terms of P5, okay? PA is actually point 1, PB is point 5, okay? PB is point 5. So we have 1, 5, and then 2, we have this is point 2 should be. Yeah, I think you know what I mean. So if you were to see that if you work it out everything, you will feel that your equations are correct because you have incorporated all of the points, okay? Because I've described using, you see there's a relationship between P and P2, this one is P2 and P3 and P4, this one is P4 and P5. So you can see that I've included all 5 points inside. So maybe in the test, maybe you can write down the relationship between all of them, and then you see whether is your equation correct. And then you rearrange, and you can get your P gauge. Okay, so P gauge equals to P absolute plus some atmospheric pressure if it's open to air. Okay, let's say if this is like open to air, then this portion they will write P ATM. Then that of thing. Not this point lah, but rather than it's open air so it's P ATM. I hope you get what I mean. So I think this is the summary for all the things. In piezometer, okay, so one last summary before I knock off is that everything you have to end up, in the end you have to set our equation in terms of P gauge is equals to P absolute minus P atmospheric, is this one. And for piezometer is equals to gamma H, okay. For YouTube meter is in terms of the equation, hold on, it's in terms of this equation, okay. And then for the recent one, the pressure difference between two containers is our formulas for this one. Okay, this one. So you have to go and memorize it. Okay, I think I will suggest you go and memorize, or you know how to derive all these things. And then yeah, I'll just end this video and good luck.